The next major type of reactions we're going to talk about with alkynes is going to be our halogenations. These are going to be adding halogens, and we're going to talk about both our hydrohalogenation, adding, for example, like an H and a Br, as well as our halogenation, adding like a Br and a Br. Now, when we are doing halogenations, the choice of your equivalencies or your stoichiometry, the amount that you do, is really, really important, because you can, for example, go down just to a double bond or all the way down to a single bond, depending on your equivalencies or the amount of your brominating or halogenating agent that you use. So you do really want to pay attention to that and kind of like be specific. Now, we'll look at examples and think a little bit about like Markovnikov addition when we start thinking about our hydrohalogenation. Our first one, though, is going to be just our halogenation. And our halogenation is going to be the exact same as we saw back in our alkene chemistry. If you have Br2, it wants to form that bromonium type three-membered ring that will then be opened up on the backside, giving you an anti-addition. Exact same chemistry happens here. So if you use just a single equivalence of Br2, so a 1-to-1 molar ratio between your bromine and your alkyne, you will get a single addition, meaning it's going to go from a triple bond down to a double bond, with your bromines being on the opposite side. That opposite side is your anti. Normally, when we think of your double bonds, we normally show like wedges and dashes. Here, we're not, because we're on our sp2 trigonal planar double bond. Now, if you keep reacting, or if you do an extra equivalence, that will then add again, and that will then give you your double brominated product, which would add a Br on both sides. This is also an anti-addition. You can also go directly here if you just use Br2 and excess. Excess will sometimes be abbreviated as X and then S. That is not extra small. This is excess, meaning a lot. That's one kind of like thing that sometimes seems confusing. Or you can write two equivalents or things of that sort. There is no kind of Markovnikov or anti-Markovnikov, because you add one bromine to the left side, one bromine to the right side. Now that's going to be different when we do our hydrohalogenation. If you think of your HBr, this was our kind of very first example we thought about when we were thinking about Markovnikov. And that's going to be our addition where you add H to the side that has more H, and then Br to the side that is like more substituted. So in terms of like reaction mechanisms, you'd have that alkyne come attack your hydrogen, and then your bromine break out. And then that's going to form your carbocation, which would then get attacked by your bromine. Now, in this specific case, if you have an internal triple bond, there is no preference left or right, because they're both connected to a carbon. So in terms of your addition, you're going to simply put a bromine on one side and then a hydrogen on the other. Now this becomes a little bit messy, because if right here this is a symmetric molecule, it doesn't have anything, but if we imagine one of these sides we'll call A and one of these sides are B, you would get both this product where you have your bromine on our B side, and then you would also get your A and B bromine on the other side, and get a reaction mixture that includes both of those. This is where these can get a little bit messy and can kind of suck. So your yields will often be kind of cruddy with these. Now, once you form these, you can potentially isolate. And let's say we use some type of separation technique to get rid of that one, and we isolate just our pure amount of our first one. Even if it has low yields, we're able to isolate it. If you have a structure like this and you expose it to another equivalence of HBr, we now have a Markovnikov spot, because we now have an H on one side and a bromine on the other. So that second H is going to want to go to the H side. That second bromine is going to want to go to the bromine side. So you would then get a product where you have H and H over here and bromine, bromine over here. If you remember, this type of dihalide is known as geminal. Geminal, thinking of twin, it's on the same. So if you use, same thing here, if you go through and use your excess HBr, that's going to put both of your bromines on the same side because of Markovnikovs. Now, where you don't get this kind of like messiness in the two are going to be on your terminal alkynes. On your terminal alkynes, for example, your B, if we say like that's like the end, would be a hydrogen. So then you'd have preference. So to kind of give a specific example there, if we look at this, so we have a cyclohexane that has a single and a triple off of it. If we use, let's just say one equivalent, that's this one EQ. Here we would do just a single addition down to a double bond, and our bromine is going to go on our inside, and then our H is going to go on our outside because there are more H's, because you'll have kind of an H here and an H here. I'm going to erase those from our skeletal structures. You can then, for example, imagine doing another HBr single equivalence and then getting your same type of geminal dihalide here. Now, this is going to be a kind of like interesting kind of like set of reactions that you can consider, because if you have a triple bond, you could actually convert between your, so if you have a terminal triple bond, you could, for example, use 2 equivalents of HBr to make a geminal dihalide. Then you could use, for example, your molten KOH to then actually make an internal. So if you want to ever convert from a terminal or an outside to an internal, you could actually use this type of reaction. And we'll actually do a specific example of that once we kind of get through our reactions and we're thinking about kind of all these kind of like outside of a vacuum and putting them all together. So that's kind of our main ways to do our halogenation. Br2, add both. HBr will do single additions, and then if there is a Markovnikov spot, it will go Markovnikov. If not, you end up actually making 2 products, and then we'll kind of just like choose the one we want based on isolation. So those will have kind of lower yields. And that's our kind of set of reactions of halogenation. Again, these are just the exact same type of stuff that we saw with alkenes. That's why we're kind of going through these a little bit quicker. The only difference is we're doing alkynes. So we can do a single addition, or if we use excess, we can get a double addition. We'll go ahead and stop the video there, and then on our next one, we'll start thinking about how to hydrate or add OHs.